I'm going to graph this exponential equation. And to do that, a table is a very good way to do that. So to do a table, we want to think of numbers to plug in. Now, we have to think, what are the easiest numbers to plug into this table? And if you think about it, the easiest number of any number to plug into an exponent is 0. And the second easiest is 1. So we're now going to plug in 0 and 1, and they're really easy calculations. So watch what happens. When you plug in 0, you get 2 times 3 to the 0. Or think of it this way. I have 2 multiplied by 3 0 times. So what is 2 multiplied by 3 never? Well, wouldn't that be 2 times 1? Because isn't 3 to the 0 1? Which is 2. Isn't 2 times 3 never 2? So can we put a dot at 0, 2? All right. The next one says 2 times 3 to the first, which means I have 2 times 3 once. Well, isn't that 2 times 3, which is 6, which is 1, 6? And, oh, by the way, where's the asymptote? Well, are you okay with, isn't there really an asymptote right here at the x-axis for an exponential? So won't the graph be really close to that asymptote, never touching? And then won't it shoot up really quickly? Like that. And that right there is my exponential growth. Now here's the shortcut. I want you to get used to this shortcut. The table is always the default, but here's the shortcut. The front value is your initial value, 2. So at 0, I start at 2. This is telling you what you're doing. You're tripling. So what do you get when you triple 2? 6. If you triple 6, you get 18. So at 2, you'd be up here at 18, way up at the top of the graph. It's really quick. This is what you start with, and this is how it's changing. Done. Fast. Or you make the table. So in order to graph this one, I don't like negative powers. So I'm going to rewrite this one. What I'm going to do is I'm going to write it as y equals 10. And I want to make it an x power. I don't want to make it a negative x power. Well, if I bring that negative off the x and bring it in, 2 to the negative first is really 1/2. I might have confused you there, but if I got rid of that negative power, wouldn't that give you the reciprocal of 2? So here, do you see a decay? Aren't you starting with 10 and halving repeatedly? Starting with 10 and halving over and over and over. Let's make a table to start with. It's a little bit easier to make sense of it, to graph it. Easiest two numbers, like always, is 0 and 1. When I plug in 0, doesn't that mean I start with 10 and I half never, which is 10 times 1, which is 10. Remember, you started with 10 and never did anything with it, so you stayed at 10. So 0, 10. Put a dot there at 0, 10. Then I start with 10 and 1/2 one time. So 10 times a half is 5. So at 1, you have 5. Now we put our asymptote. Because there's no k to this problem, our asymptote is just the x-axis. This hasn't had a vertical shift yet. And do some of you see a pattern here? Don't you start with 10 and aren't you halving? So you have 5. What would it be at 2? Well, what's half of 5? 2.5. It's kind of interesting. And what's half of 2.5? 1.25. What's half of 1. You can keep going if you wanted to. Can you see the trend? You just keep halving the previous. Oops. And the graph looks something like that. So you can always start with the 10 and just keep halving, or you can make the table. It's your call. Just don't forget there's an asymptote right here at the x-axis. Alrighty, for this graph, we are starting with -2, but we're taking e to the x power. And we have a vertical shift. Now, e to the x power means it's going to be a growth, a continuous growth. But it started with a negative, so it's going to be an upside-down graph. So it's going to be an upside down, and there's going to be a vertical shift up 3. So the first thing I want to do is I want to write my horizontal asymptote, which is y equals 3. That right there is your horizontal asymptote. So let me draw that on. I'm going to draw my asymptote at y equals 3. Remember, that's where it's going to cross. It's going to come up to but never cross. Next, I'm going to make a table. I'm going to choose some nice values. Usually, again, we use 0, and I'm going to do 1. 0 and 1. So when I plug in 0, I start with negative 2, and that's e to the 0 plus 3. Anything to the 0 is 1, so that becomes negative 2 times 1 plus 3, which equals 1. So I have a dot at 0, 1. This is the next part. Negative 2 e to the first. You could put parentheses if that helps. Plus 3. Now, e is about 2.7. All right. So what I have here is 2 times 2.7, which would be about 5.4, or close to 6. Are you okay? It's about close to 6, but 5.4, 5.5. So I got 2. So what I have here is I got negative 5.4 plus 3. What does that give you? Negative 5.4 plus 3, is that negative 2.4? So at 1, you're going to be down at negative 2.4. Now, isn't this a growth, but it's upside down? So some people struggle with, how do I connect these dots? Well, hopefully you can see it's an upside down growth. A growth normally looks like that. A growth normally looks like that. So this one's going to go like that. It's a little tricky for some. So it's going to kind of be close here. And then it's going to shoot down like that. It is an upside down continuous growth with a horizontal asymptote at 3. Now here's a shortcut, kind of a shortcut. Isn't this normally where you always start, in negative 2? Isn't this first dot 2 below the asymptote? See the asymptote? Then I go down 2. Now the problem is getting this dart's a little bit confusing with e's. So the shortcut doesn't really work on e's, but it does help you get that initial value. This front is always how far it is away from the asymptote, down 2. First thing I want to do on this one is notice that negative x power. Let's make it a positive x and write the reciprocal of what's inside. That really helps on these kind of problems. So this is a 3 out front. The reciprocal of 1/4 is 4, and it's now a positive x. That right there is quite a bit easier. Can you tell this is starting with 3, and I'm multiplying by 4 repeatedly, and it's dropped down 7. So my horizontal asymptote is y equals negative 7. So let's put a horizontal asymptote at y equals negative 7. It is a growth because it's a positive 4 bigger than 1. So I know my graph will look something like that. It's going to be going up. Let's make a quick table. If I make a quick table, always going to put in 0 and 1. They're my easiest. When you plug in 0, you get 3 times 4 to the 0 minus 7. 4 to the 0 is 1, so 3 times 1 is 3. And 3 minus 7 is negative 4. Then we plug in 1. 3 times 4 once is going to be 12. 12 minus 7 is positive 5. So can we plot those dots? Can we plot 0, negative 4, and 1, 5? And we talked about it being a growth. So won't it come up along here and then shoot up rather steep And it would look something like that. Now the shortcut for this one is I start at 3 above negative 7. Do you see right here? I'm going to have 1, 2, 3. Then, doesn't 4 mean I'm going to multiply 3 times 4, which is 12. So here, can I go up 12, which is 5? That's a shortcut. If you see that you start with this, you multiply by this to get the second dot, put your asymptote, and you can quickly sketch. But in the end, it's probably easier just to do the table.